Okay, welcome guys back to another Leetcode video, and in this video we're going to be going over converting a 1D array into a 2D array. So the question reads out we're given a zeroed index one-dimensional array, which is named original, and then we have two integers, the row and column m and m respectively. And we're tasked in creating a 2D dimensional array with m rows and n columns using all the elements from the original. Okay, that's the main gist of it. Okay, so we've seen this example. It does that. You create a 2 by 2 matrix with 4 elements. That makes sense. And then they convert this into a 2 by 2 matrix. And we have this example. We see that we have 2 elements and we want to fit it into a 1 by 1 matrix. But we know a 1 by 1 matrix can only have one element. So this can't be made into a 2D matrix and then return an empty array. Okay, that's pretty interesting. So what I like to do first is just initialize an empty array called a matrix, and we're going to be appending values to this later, and I'll be showing you guys how we do that. Well, the first condition we want to check is if we can even make a 2D matrix with the given matrix and the rows and columns. So if m times n doesn't equal the length of the original, so if m times n doesn't equal the values that were given, then we cannot create a 2D array, obviously, because we can't create a 2D array without having the right dimensions. Okay, so then after that, we just return an empty array, is what they told us to return. But if we can create a 2D array matrix, we have to actually have some kind of logic to be able to do that. Okay, so how I like to do this, so we notice that for every value, for every row, let's say we're creating an m by n matrix, right? It's always going to have 2 rows. And if we create like a 3 by 2 matrix, it's always going to have 3 rows wait. I'm so sorry, guys. It's always going to have 3 rows and 2 columns. So we can tell the result list of this one's going to be 3 because it's going to be like that, that, and that. So the amount of lists, the amount of the amount of lists we have in our list of equations is always going to be equal to the rows that we have, because that's how we just make rows in Python. So if we know that, the length of our list is entirely dependent on how many lists we have. We can just create a for loop that says for I in range m. Okay, so now we're going through every row and we're going to create a 2 by, and we're going to create the list, the columns for each row. So for column and row, we know that we have a matrix, and to append into this matrix, we want to append this stuff. So how do we get the index 0 to index 2? Well, we know we can just do m times I. And why can we do that? It's simply because for this equation 2, this example is really good for this, because we know that for in this equation we have on the first iteration when I equals 0, and we know n is always going to be equal to 2, we're going to get 0, right? That makes sense. And we want to get 2. So how do we get 2? By splicing the array. We want to do n times I plus 1, so we can get the ending value like this. So when we get 1, 2, 3, 4, in Python, arrays are 0 index, so we start from here, and we know that in Python when we splice something, we want to end at this element. We never include this element in our result. So what this is effectively saying is that get these elements, right? And then in our second iteration, when I equals 1, so when I equals 1, and it's still going to be 2. So in this array, when we use our algorithm, the n times I plus 1, so we know n times I is going to be 2, and n times I plus 1, well, that's just 2 times 2, and that's going to be 4. And then we're going to get this half of the array. And yep, if we could just keep appending these values into the array, then we're always going to get the result if we just keep appending these original slices. Okay, so now that we know how to do that, we just say original matrix dot append original n times I plus 1, because we want to access it from the original. And when we run this, it should work. Oh, I forgot to actually return the matrix. So return matrix. And let's see what we get. So I got an acceptance, and it works for every edge case. So let's go ahead and just submit this, and we can see that our solution runs pretty well. So it beats 90% of people, so that's pretty good. So thank you guys for watching this. I hope it was very useful, and I hope it was very comprehensive, because I try to make this as comprehensive as possible. So thank you guys very much for watching, and I'll see you guys in the next one. Bye.